Very good morning. Welcome you all to the NPTEL course on Advanced Distribution System Analysis and Operation. Now, after understanding the ancillary support system, we will look into how TSO-DSO system can engage or promote ancillary support in a very successful way. So, ancillary support from distribution grid to transmission networks. So, TSO-DSO coordination schemes for acquiring ancillary support. So, centralized ancillary support market model. We will also get into local ancillary support market model, shared balancing responsibility model, common TSO-DSO ancillary support market model and integrated flexibility market model. In the past, we have seen during the previous lecture different TSO models, but now we will focus today TSO-DSO models for ancillary markets. So, these are the 5 different models we will be discussing. So, 5 coordination schemes are analyzed corresponding to different topologies, centralized, decentralized and roles of the network operators. Centralized ancillary service market model, TSO contracts services directly from DR, no congestion management is carried out for distribution grid. TSO, DSO, we can see TSO, we can see DSO, they are integrated and flexibility resources at high voltage, that is market bit given to TSO. Then we have DR at medium voltage, DR at low voltage, they both are connected to my aggregators and then aggregator further provides to TSO or maybe to DSO. So, this is how the arrangements are and indirectly this is aggregation and pre-qualification, this is what you see here and then you have market bits. So, this is basically the structure is known as centralized ancillary service market model and we will move to a local ancillary service market model, a slight difference, not much. DSO manages a local congestion market, unused resources are transformed to the ancillary service market managed by TSO, procuring, balancing and congestion management process. Now, when we talk about flexible resource at high voltage, so they are connected to my transmission system operator which is a centralized market and the aggregator which talks to the DSO, but in the past it was talking to the TSO and the DSO will further talk to the TSO and DR at low voltage and medium level are connected to my aggregator. So, this is basically a local ancillary service market model. So, the focus managed at this level and then finally the DSO is only talking to TSO. The previous model if you could see the aggregator used to speak to TSO, but here the aggregator speaks to my DSO. Now, we will move to shared balancing responsibility model where TSO transfers to DSO balancing responsibility for distribution grid. DSO manages a local congestion and balancing market using local DRs. So, similarly the flexible resource at high voltage is being connected to TSO and the DR at medium voltage and low voltage are being connected to aggregators and finally the aggregators provide information to my DSO. And then the TSO and DSO they are interconnected and TSO transfers to DSO balancing the responsibility of distribution grid. So, DSO become more responsible here. Now, the common TSO-DSO ancillary service market model, the TSO and DSO manage together a common market, very important. The TSO and DSO together manage a common market, balancing and congestion management for the whole system. So, anyway the flexible resources at high voltage will get into the TSO and DR at medium voltage, DR at low voltage will be supplied to the aggregator and then aggregator now provides the information to a common marketplace of both TSO and DSO. Integrated flexibility market model, This is very, very interesting because instead of DSO, TSO, there is a new player known as ISO now. TSO, DSO and commercial market parties contract D in a common flexibility market. So what exactly happens here? The TSO is now responsible to or indirectly TSO provide all the information to ISO, DSO provide all the information to ISO. So ISO is the kingmaker here, and then ISO receives all the flexibility generation from high voltage, and the aggregator which receives flexible DRs from medium voltage and low voltage and further provide to ISO. So if you look at this scenario, excluding bit of engagement between aggregator and DSO, the ISO is taking the full control now, getting all the flexible resources at high voltage, TSO and DSO. It's a very interesting integrated flexibility market model. Most of the North American systems do work under this model. Now, if you comparison between key elements in different coordination schemes, so we'll just try to understand what is centralized ancillary service scheme and what is local ancillary service schemes. So, in case of centralized ancillary service schemes, the role of the DSO limited to possible process of pre-qualification, and the market operator, common market is TSO, and allocation principle of flexibility from distribution grid, priorities for the TSO. However, in case of local ancillary service market, the role of the DSO is the organization of local market, buyer of flexibility for local congestion, aggregation of resources to central market, and the market operator, which is both TSO and DSO, and the allocation principle of flexibility from distribution grid, the priority is given to DSO. Now, if you move to shared balancing, the role of the DSO is to organization of local market, buyer of flexibility for local congestion management and balancing. TSO-DSO become my market operator, and the allocation principle of flexibility from distribution network exclusive use for the DSO only. Integrated flexibility, role of DSO is buyer of flexibility for local congestion management, market operator, which is independent market operator, and allocation of principle of distribution flexibility, whoever the highest willingness to pay. Finally, the common TSO-DSO scheme, where the role of DSO is to organization of flexibility market in cooperation with DSO, buyer of flexibility for local congestion market, and the market operator, which is common market TSO and DSO, and central market TSO and local market DSO. In case of allocation of principle of flexibility from distribution grid, it is the minimization of total cost of TSO and DSO. Let us also understand bit of real life technological pilot projects being executed across the world. We'll take care of three pilot projects. One is at Italy, the second one is at Denmark, and the third one is at Spain. Now, the coordination scheme is centralized for pilot A, and common TSO-DSO for pilot B, and shared balancing responsibility for pilot C. Now, services to be gathered by TSO-DSO, it is the aggregation of information for TSO, voltage control for TSO, frequency control for TSO. Now, in case of pilot B, it is the DSO congestion management, frequency control for TSO, and in case of pilot C, the responsibility are DSO congestion management, frequency control for TSO. Now, if you look into the D providing flexibility in case of pilot A, that is for Italy, it is run-of-river hydropower plants. Now, in case of pilot B, it is impulsion pumps for heat water for indoor swimming pools. And in case of pilot C of Spain, backup batteries for radio base stations used in mobile phone communications. That is how the DRs provide flexibility through different projects or pilots. Now, what are the main focus for these pilots? For the pilot A, which has been executed in Italy, where the TSO-DSO communication, that is TSO controlled assessment of DR capability to participate in markets, In case of pilot B, Denmark based, which provides price signal from aggregators to obtain DR flexibility, communication chain from market to DR through aggregators. In case of Spain Pilot 3 model, monitoring of distribution network, creation and operation of local flexibility market, assessment of base station capability to provide services for grid support. Now slowly let us move into a T&D market mechanism. So there are different TSO-DSO coordination models. Now at the core of any TSO-DSO coordination model in open market environment is the consideration of distribution network constraints to facilitate and ensure the effective provision of DR services to the TSO. Now, by catering for voltage and thermal limits, it will be possible to validate service bid made by distributed energy resources to define which services can be allowed without affecting the integrity of the distribution network at a given time. The efficient use of DRs in the management of the grid requires adequate amount of information exchange between TSOs and DSOs. It will also provide the information about the extent to which the DRs can be exploited to obtain flexibility services without violating the grid service conditions. I think 3 such coordination models will be discussed in the next slide. Let us focus on TSO-managed model. With this model, the TSO is responsible for the DR and TR dispatch, that is a fully centralized dispatch, while accounting for both transmission and distribution network constraints. TSO, which is basically bits validation at 2A, and in case of real-time operational data, which is 1B, and dispatch command, which is at 2B, and bit submission, which is at actually 1A. So just focus on what we are doing is, first of all, the DR sends their bits directly to the TSO for a given service period, that is for 1A. The TSO also receives real-time operational data from the DSO, which is considered to be 1B, and then the TSO performs a centralized validation DR services bid, that is 2A, and computes the dispatch of TR and DR. The corresponding dispatch commands are sent to DR, that is 2B. So we have 4 commands, 1A, 1B, 2A, 2B. As you could see, the 1A lies here, 1B lies here, 2A lies here, 2B lies here. And now we have a DSO, DR and TSO, 3 components, and how do they comment? So 1B to 2A, and then 2A to 2B, and then DR to TSO is my 1A. So DR communicating to TSO for 1A, TSO itself is taking care of 2A, TSO to DR through 2B, and DSO to TSO through 1B command. So this is how the TSO managed model takes care, means indirectly how TSO manages DSO and DR and what kind of commands are being exchanged. Now there are a bit of advantages that we experience through TSO managed models, such as simplifies the TSO-DSO coordination processes. TSO know how on dispatch. TSO has no conflict of interest when pushing distribution network assets to the limits, and a bit of challenges too, likely to have a less efficient facilitation of DR services, and huge computational and modeling challenges for the TSO, and then high amount of operational data transfer between TSO and DSO, and TSO lacks know how to distribution network. So there are a bit of merits and limitations of a TSO managed model, but however, TSO managed model is quite popular in recent times. With this, we come to an end of today's lecture. Thank you, patient hearing. Bye-bye.